No recreation now until it's finished.
True.
Okay.
Latent heat.
Latent heat. Okay, wait for that. You got it?
Yes.
Can you fix that, Tekken? It just the highlighter is fallen. Yeah, just lift the projector up and move the highlighter. It's a little crooked. Move it this way. No, stop. Lift the projector up. This way a bit. Up, too far. No. Yeah, down. Yes, down. Yes.
Oh.
I think the cable's on the back. Yeah. Why is it so crooked?
There you go.
You know the remover, the lighter, it's not flat. It's edgy.
Oh, that's worse.
What's your wallet?
Yeah.
There now. Uh-oh.
Press the word.
The heck happened? Oh, here we go. Right, latent heat.
That's correct.
Okay, you got this?
Yeah.
Yep. Alright, so first thing I want you to do, imagine a block of heat, block of ice. Block of ice which is slowly being heated. Yeah. A fixed amount of heat is being pumped in per second or per time. For example, so imagine you have some water and you're putting in 4,200 joules into the water per second, and it's a kilogram of water. So what would happen to the temperature? You have a kilogram of water and you put into it 4,200 joules. What happens to the temperature?
It will move up.
How much?
1 degree every second.
1 degree every second. So if you had a power input of 4.2 kilowatts, the temperature of ice will increase. In fact, as you said, it will increase 1 degree per second. So the reason for that, as you know, if you have a kilogram of water, the M is 1, the C is 4,200, and how much energy am I giving it? 4,200. So from the formula, delta Q equals MC delta theta. The M is 1, this is 4,200, this is 4,200, so you end up with 1 equals delta theta. So if you put 4,200 joules in, the temperature will go up by 1 degree. Okay? So when we picture the graph, we're picturing as the time is here and the temperature is here, it should increase. Or another way of thinking about it is, the more energy you put in, the hotter it gets. Yeah. So let's have a look at the graph.
Direct proportion.
Yes, linear. So let's have a look at the graph. Now you see, you don't quite get a straight line. If the ice started at minus 100 and you start putting heat energy into it, it will increase in its temperature. But then all of a sudden, it no longer increases in temperature. The temperature stays constant even though you're putting more heat into it. After a while, the temperature will increase again until one point is reached where you continue to put heat in it, but it's not increasing in temperature. It's staying the same. You put more heat in, it's staying the same, and then eventually it will increase in temperature again. So you can see that these two locations on the graph where the temperature doesn't increase, it stops. And
what
why?
happens if it's under minus 100 minus 100?
Here?
Yeah, it's gonna be like constant there too.
Here, the temperature starts at minus 100. Yeah?
No, I'm just saying that the window is like 100 temperature.
The window?
I mean like the gap, after 100 is staying constant.
Here, it's constant.
Yeah.
At 0.
And after 100 it's constant.
And at 100, it's constant.
Because they need energy to change state.
That's it. So what's happening here is when it reaches 100, it's solid still. Come on. It's ice. When the ice reaches 0, it will start to melt. This melting requires energy. The energy which was causing the temperature to increase instead is causing it to change from a solid to a liquid. Then when it reaches 100, the energy no longer increases the temperature but instead changes the liquid to a gas. Then once it's a gas, it can continue to warm up again. They often, no sorry, not often, but they have on occasion asked you to draw this graph for ice becoming steam, where they put temperature on the y and energy or time on the x. I want you to copy this down as best you can. Don't have to be perfectly accurate, but you need the names.
Do I need to mention when the energy stops increasing or something?
It just,
The temperature,
we
sorry.
just need the graph right now.
Could you specify where this entry point is?
Which point?
The first constant point.
This one happens at 0.
No, the x-axis.
Oh, you don't need to worry about that, okay? It's at 500 kilojoules, but that is not important right now.
Changing state.
Yeah, don't forget to write the words, please. Did you write this down? Did you write the words in as well? Did you put at least a name on the x and the y axis? Did you? Show me. Turn it around and show me. Oh, goodness, it's hideous.
Where's constant?
Oh, dude. Alright, fine. It's like someone ate a physics book and threw it up on a page. Right, you got this?
That's right.
Huh?
That's better.
Okay. So, there is energy required to change it from a liquid to a, from a solid to a liquid and a liquid to a gas. So this gives us the concept of latent heat. So latent heat is the energy you need to change a unit mass of a material to change its state to a different state without a change in temperature.
Write that down.
Now, this was in the exam last year, and all the students got it wrong because they forgot to write without a change in temperature. So latent heat is the energy required to change the state from solid liquid gas to a solid liquid gas without changing the temperature. That is latent heat. Got this written down? Have you?
Just
So just a bit of vocabulary. When I say latent heat diffusion, that's the energy to go from, does anyone know? Melted. Solid to liquid.
Exactly.
Latent heat of vaporization is the energy to go from,
Liquid to vapor.
nobody calls it
Yes,
vapor, liquid
water
to
liquid to gas. Steam.
gas, yeah. So it's in other words the energy for boiling.
You wrote in American language.
I'd like to use that when possible. It's a feature of me. Got it? Let's do this. So, the formula, sorry, do you have it, Karar? Yeah. So, the energy, this is a formula now. The energy you need to change the state, not stat, of a mass of a material, but not to change its temperature. So, in other words, the formula is this. Oh, Stephen, why did you write delta theta there? That's so not cool. There's no delta, it's just ML.
Because there's no change in temperature.
Exactly.
ML.
ML, just ML. Mass multiplied latent heat. I'll fix it right now. Right, firstly,
No rush, take your
We
time.
didn't for Christmas that last year, last year.
that's because these are new slides. I didn't have slides last year.
Really?
Yeah, you should feel special.
You didn't make anything for the previous year, like students?
No, I just wrote it on the board. Right,
You should feel special.
don't need this delta theta business here. And what else do I need to change? A block of heat, wasn't it?
Yes.
That was
Yeah.
State.
I changed state, don't worry.
You should write a program to correct your grammar.
If I could do that now, I'd put all the EAP teachers out of business. And they have trouble with work anyway, so don't make their lives more difficult. Right, let's open this. It looked like my program crashed. Right, anyways, I'll write the formula down here. The formula is actually this, okay? File is damaged. Nice. Yeah, nice.
Does your program crash?
Not usually. I'll write it down here.
But why would your program crash?
Just only in the class because of you.
Because of you, KJ, alright? I didn't want to say anything in front of the other students. Right, this is the formula, so write that down, please.
How to make an app?
Do you? And what will your app do? Tell me.
I don't know it.
Do you just know you want to make an app, but you don't know what you want to do?
Yeah. It's hard
Physics
to,
app?
it's hard to
No.
explain.
No? Alright.
Physics app.
Please.
Nobody will use it.
That's, that's too lame.
It's not that lame. Right.
From his mouth is. Oh.
Right. Back we go. So we have this formula, yeah? Okay. Now I want you to take some values down. So water will freeze at 0 Celsius,
Yes.
obviously. And water will boil at 100 Celsius, obviously.
Yes.
The latent heat of fusion for water is 334 kilojoules per kilogram. In other words, if you have a kilogram of water, if you have a kilogram of ice and you want to melt it into a kilogram of liquid water, that's how much energy you need. So note that value, please.
I know that.
You know the number?
Yeah, like 3 0 and boil 100.
No, I know you know that. The third one I want you to write down.
Oh, my phone's in. What's that?
Kadim Sharufi.
Okay, yeah. I don't need to ask him.
Right, you have this? Okay. Now, if you want to change your liquid water into steam, you need a heck of a lot more energy. 2265 kilojoules per kilogram. Got that?
No.
Yep.
Yes.
Right. Note that water could be a liquid at 100 Celsius. So, for example, when water first reaches 100 Celsius, it's still a liquid and it needs more energy to become steam. So, it could be both at 100. Likewise, the same true with ice. You know, water could be solid or liquid at 0. Right, let's. Imagine a block of ice at minus 20, which is slowly being heated in a microwave oven. So what happens is it starts at minus 20, then it'll increase its temperature to 0. Right? Obviously, you can put ice in the microwave. But its temperature doesn't increase. It will remain solid at 0 for some time as it melts. The solid ice will melt into liquid water. The water will be at 0. Then what happens? The water will start to warm up until it reaches 100. Then what happens? It will remain at 100 for some time while it boils. The water is now steam at a temperature at 100 first. The steam will start to warm up. Okay? So it's good to have a picture in your mind of the whole process. I don't need you to write this down, I just need you to use your imagination or whatever it is you have to picture this. That's okay. Fall not found. Yes. Right, anyways, more importantly now, let's have a look at some questions. So, firstly, now did you write those two values down for the latent heat earlier? Yeah. So, how much energy do you need to bring ice at 0 to steam at 100? Okay. Yeah, well, write that down first. Yeah.
You have private classes?
Yeah, every day.
How many?
Two tonight.
Just 2 students?
No, two different students. Yeah, well, I mean, like one student and then another, not two together.
Why not together? You can move one and
Because they're like 4 years apart in age. That's why I can't do them
no,
together.
same batch, same, like grade or something.
Nah, each student has their own problems and needs. I couldn't really do that.
So that means you can teach us individually.
I could if you paid me individually.
Like we should.
But I don't get paid per student. I get paid per hour.
Should make your own like half a small academy. Learn more.
What if you
Academy?
get paid per hour? Do they count the break as well? Like when you have a break.
Yes, I guess so. But that's normal. Everybody gets paid for their lunch is included in their pay.
Yeah.
That means you just take anything from the cafeteria.
Huh?
That means you just go to the cafe and take anything.
No,
Okay,
no, no.
okay,
I have to bring in my own food. Come on.
You know, in the salad they just add a little bit, right?
Huh?
Yeah.
They add what? They add
Like, you know, it's a basic salary, fuel thing.
No, no, it's basic salary.
That's all.
That's
Over
all.
here.
That's it.
Yeah.
You don't get mobile balance stuff in the petrol and
I wish. No.
Huh?
No, there's no top up for petrol, mobile phone, none of this. Sorry
none
to
of your
disappoint
travel
you.
costs.
Oh, no, oh, no. They don't even have to pay for my own bus. Come on.
No,
Sorry.
I feel fine.
Yeah, you should. You should really feel sorry for me. Yeah. Alright. Did you write this down?
Yes.
Yeah. Now I never wrote down the mass, so we'll make it a kilogram.
Okay.
Okay, a kilogram. So we'll have a kilogram here. Actually, so I don't forget, I'll write it in here. Bring a kilogram. Alright. Okay, so what's the first step in this process of changing the ice into water, steam? So here's the ice at 0 Celsius. Then what happens? Does it start to warm up if I heat it?
No.
No. It will change into
Liquid.
a liquid. At what temperature? 0. Then what happens next? The liquid will warm up until it becomes 100 Celsius, and then finally it turns into steam at 100 Celsius. So the way I see this problem as having 3 parts, 1, 2 and 3. The first part, the energy to change the ice into water. The formula is delta Q equals ml. What's the m here? What's the m? What's the m?
Mass 1 kg.
1. And what is the latent heat of fusion? 334 kilojoules.
Mhm.
So the answer is 334,000. Now the next part, what formula do I need for the next part? Part 2.
Uh,
1 kg.
MC
MC delta
delta
theta.
T.
14200 and the delta theta 100. So the answer is 42000 joules.
And why did you use another formula in the second step?
In the middle step, it's still liquid and it's still liquid. It's just like last time.
Okay. Uh-huh.
This is going from solid to liquid and liquid to gas.
Okay.
Like 4,000
There are too many zeros.
There are not.
This is not meant to be 100. It's meant to be It's not meant to be 1,000.
Oh my goodness, you're right. There was one too many zeros. Alright. And the last one, what formula do I need for the last part, part 3?
ML.
ml, and m is 1, and what is the latent heat of vaporization?
2265 kilojoule.
2265, that's huge. So if I add all 3 together, I'll get the energy.
Very good, bro.
Oh, it is.
Just imagine how much money you make off.
I wouldn't work again.
3019,000. Or if you want,
Divided by or what?
just add the 3 together.
3 million.
3.02 megajoules.
So still 100%.
Million.
It's a lot, isn't it?
Yes.
Yeah?
Like the first two cases are the same, liquid. Both
Okay.
of them are liquid, okay?
No, solid, liquid, gas.
Say you use a 3000 kilowatt microwave.
How long will it take to do this? Well, no, microwaves aren't 3 kilowatts. That was my made up one. 1200 maybe is what you have? So it will take 42 minutes.
What?
Oh yeah, seems crazy, doesn't it?
Anyway, 1 kilogram of ice is big.
1 kilogram ice is pretty big, yeah. This sounds like something you could do. It shouldn't set off the smoke alarm.
1 kg ice would take 42 minutes to be steamed.
Yeah.
In a regular microwave, to do this actual problem would
Yeah,
take
that
42
takes
minutes.
42
Yeah,
minutes.
yeah. I was thinking of small ice cubes.
So it's
Yeah,
gonna be like
a
this.
kilogram would be, well, a kilogram would be a pretty
Like
big block, wouldn't it? And it's not like you want to turn it into liquid. You want to turn it all into steam, to have nothing left in the microwave. Just open it up and all the steam comes out. Yeah, exactly. I don't know if it's safe for the microwave to have a kilo of steam stuck inside of it. I'm sure that there's fence at the back of microwaves,
Yeah.
isn't there? So yeah, so what you want is to open it up 42 minutes later and it's completely empty. Let's do this sometimes.
Yes.
There's a microwave in the teacher's room.
Student union.
Student union? What could possibly go wrong?
Exactly.
Alright, next question.
I think
Oh, we can request the
so the camera
principal
does
to
not
buy
see.
a second hand, maybe.
Maybe. Alright, next one.
Guys were just start fixing that.
Okay, write this one down. 200-gram cup of water has 10 grams of ice added to it. They are mixed together and reach thermal equilibrium.
I don't know.
200 gram.
You should buy that. If you want to excel in math. Or 100% math.
Got this?
Yeah.
Okay, can I do it now? No?
It's like a laptop.
Oh, it's not like a laptop.
Let's see.
It's
Okay,
like a
let's
palm
do
top.
this.
You know palm top?
Yeah.
Yeah.
Arrow.
Thanks, K to the J.
Okay.
I told you about the table quiz tomorrow, didn't I?
Which quiz?
The Friday, tomorrow's Friday.
The table quiz. Did I tell you about it, did I?
Which quiz?
Table quiz tomorrow.
Oh,
Yeah.
yes, yes.
You know there is one tomorrow.
Yeah.
Yes.
2.
And you know what a table quiz is, don't you? Put that in the bin then, thanks.
Different questions, different teams.
Yeah, Steven's on my team.
Yeah, the teachers will be at some of the tables. Now, I'm just saying, last time we did this, the table I was at
Yeah.
won. Just keep that in mind.
I'm on the other side, I'm on the checking side.
Yeah, well, on this side.
I
I'm
had-
on the checking side, correcting, I was
Exactly.
correcting your first paper.
Okay, okay.
Me and Colin were on the winning table with the other students.
That is the left
I'm
side, right?
this time I'm loading.
What do you mean?
The left side of the table.
I don't know, last year when we did it. Anyways, if you want to be on a winning table, I tell you who's really good at table quizzes. Connell.
Yeah.
Connell.
Yeah, true.
You want to be at his table. He knows a lot about things.
You want to be there?
I'll be there.
So maybe your table.
I know, I only want good students at my table. I'll tell you whose table to not go to.
Like.
Stephen Bruce. Stay clear. You want to go to a science teacher or a older teacher, like Mark. He's very good too at table quizzes. You know Mark, don't you?
Yeah.
Yeah,
This
no.
teacher.
But he explains in detail, so I get bored in his class.
But he's still good at table quizzes.
Stephen, one day I called my
He's
friend.
got good sports knowledge.
One day I called my friend and Mark answered me, okay? He said, hey, I swear, okay? I said, hey Mark, how are you? No, I'm not Mark. I am your other friend, Frank. I said, who's my other friend? He said, Stephen. You know him? I said, yes.
This is Mark.
Yeah, I don't know. He was in the class.
Yes, okay. Yes, I did that today on a student actually. You know the fella in intake 2, Remo, you know him? His Chinese friend is Long.
Okay.
You know them? No, alright. Long was called Remo, so I answered the phone. I said, hello? He said, hi Remo. I was like, no, this is Stephen. Who? His maths teacher. Who? Alright, did you write this down?
Yeah.
Now, how much water do we have? How much water? 200 grams. And the ice?
10 grams.
How much?
10 grams.
10?
Ice.
10 grams.
Yes.
Right, now here's the question for you. What temperature is this at? If it is in... No, listen. This is mixed together, so it's in thermal equilibrium.
Mm-hmm.
What temperature is it at?
0.
Why?
Because of the ice.
The water and ice are the same temperature. That is only possible if they're both 0. For example, if this water was at -1, it wouldn't be water, it would be ice. If this was at +1, this wouldn't be, this would be water, but this wouldn't be ice, it would be water. So the temperature at the beginning for both of them is 0. And we want to know what's the or how much energy I need to make it into a temperature of 10. So there are 3 parts to this. 2 parts really. Part 1 is that the ice must become a liquid, and then part 2, the liquid increases to 10. So part 1, how much energy do I need to convert the ice? What do I need? I need ml, which is 0.01. Now, sorry, what was the one for ice? 3. What's the value for the fusion for ice?
334.
334,000. Okay, so 334,000. Well, this is obvious. 33340 joules. Now the second part is the energy.
Ooh.
What's wrong?
3340.
There's just 1 0?
No,
Which
you
one?
wrote 333.
Hang on.
In the answer says 333.
Oh. 3, yeah, too many 3s. Okay. MC delta theta. So what's the M for the next part? The liquid increasing in temperature by 10 Celsius.
10 minus 0.
No, what's the M?
0.2.
No. Yes, maybe continue. 0.210. The C would say 4200, and the temperature?
0.210.
10. Minus 10. Yeah. 10.
8820 joules. So you need in total 12160 joules. Yeah,
That's total.
total. Yeah,
Yeah.
you got this? Yes? Not yet. So you mix some, yeah, write this one down please.
Oh my goodness. I don't remember this question.
What's that?
So I'm looking for N.
Yeah.
Your house at the beach or near the beach?
Near the beach.
Near the beach, actually.
You're near the beach?
About 200, 300 meters.
Oh, that's fine.
So you can walk.
Oh, that's
What are you doing at the beach? There's no sun.
still nice. Come on, it doesn't have to be sunny. Alright, did you write this down? So, if you look
Yes,
here,
one second.
ah,
Right, total.
Is it a nude beach?
do you know how cold it is here? It's not possible.
You know, when we used to walk at the Friday dinner outside,
Yes.
so me and this guys, they don't get cold, they're wearing like half dresses. We should, make a video or something and should ask questions to the people.
They're used to it. You're coming from Saudi and Nigeria. Yeah. Alright, okay, so what you have here, what temperature is the water at the beginning?
0.
Is it?
Yeah,
No,
10.
15.
10.
15.
Sorry, 15.
And how much water do I have?
300.
0.33, yeah.
No, 3, 3, 0.
And then I have my ice. And what temperature is the ice at?
0 degrees.
Yeah, I did say it. 0. And how much ice do I have? X. Got that? Now what happens is I mix it all together and the final temperature is 5 Celsius. How much ice did I add? So there's two parts here. The water. Is the water gaining or losing energy? Losing. And the ice? Gaining. So how much energy does the ice gain? Well, yeah, that's the mass. The energy, well, first the ice must become a water. So that's M, which we don't know. L we do know. What's the L for the ice?
3, 7, 3, 4.
333
4,
4000. Yeah?
Yeah.
Also, the ice then has to warm up. So we have MC, and then this little bit of ice that changes into water, it goes from 0 to 5 at the end.
That is
5 at the end. So that's the 5 here.
Yes.
Now, how much energy does the water lose? Well, the water would lose M, C, delta T, which is, it goes from 15 to 5, so it loses 10. So you have 334 000 X plus 4200 times 5, 21000x equals 0.33 times 10 times 4200. 13860. So the water that is lost by the energy that is lost by the water must equal the energy which was gained by the ice. That's this one must equal this one. So you make this equation. So let's calculate.
Are your zeros alright?
I sure hope so. But now I'm starting to question things. Something does look wrong, huh?
Very, very wrong.
Yeah, why? Are you sure it's 334
Yeah,
treble
it's
zero?
clear.
Are you sure?
Yeah.
Are you
Yeah, but there are 4 zeros.
But you
Yeah,
have
you
four
have
zeros
4,
four
again.
3, 4, yeah.
Damn.
Dang, indeed. 1386 divided by 2100 plus.
You want that zero only.
Yeah,
Four
yeah.
zeros.
So I get x equals 0.041. So the answer is 41 grams of ice. A sensible answer.
Yeah.
Right, let me give you the homework then.
I told the most homework. No.
Bam! Homework.
Fine.
Right, picture that.
For Monday, right?
Next physics class.
On Monday.
No,
Again,
is it? Oh, it is Monday. No, I won't have time to.
What's wrong with my cup? What? I was just seeing rainbows going across. Nothing is wrong with my camera.
It's coloring?
Did you get this?
It's getting colors.
Yeah, it's it's
I'm
making
closing it now.
Wait.
Look.
Wait. Get in the color, bro.
5, 4, 3, 2, 1.